Dave Scahill and Sandra Ampudia from Discovery Source will be exploring the language of STEM. This session is designed to help teachers be more intentional in their use of questions and vocabulary to support higher order thinking when working with young children. Join them for this training session in Breakout Room 3.
Hi everyone, my name is Dave Scahill and I'm the founder and CEO of the Discovery Source, and I'm happy to be here today with Sandy Ampudia. Sandy, thank you for being here. You want to say hi to everyone?
Hi, welcome to our session. We're happy to have you here. We hope you enjoyed the session that we prepared for all of you. Welcome.
Welcome to the language of STEM. So we are going to talk about the importance of asking questions and engaging in conversations with young children around science, technology, engineering, and math. So Sandy, would you like to take it from here?
Sure. What are we covering today? So as you see in our agenda, we're going to reframe a little bit of the most important pieces of cognitive development and how we can relate this with the STEM. Then we're going to see why questions help, why building questions and being very intentional about the questions that we provide in our settings will help to support cognitive development. And then we're going to go deep into the art of questioning, because we all know questions are important, but do we know how to target, how to select the questions? And then we're going to give you a couple of ideas, key ideas to enhance questionings. And then we're going to enhance the presentation with a couple of activities that we know you will enjoy in your classrooms, and how we can prepare activities and a set of questions that will go along with all of it. But before we start, and knowing that you're here among many other presentations, would like you to think about what is in it for me in this presentation. What are some of the expectations that you have for this session? How do you think we can make your days easier, enjoyable, after we complete this session? So if you want to take a couple of minutes and write down a couple of ideas, a couple of expectations that you have for our session today, and check and see towards the end if you complete some of the expectations that you have for today's session. Now, let's think about that quote that we have in the screen. It says, cognitive development in young children. So listen to this quote. It says, the use of chemistry, physics, and math. They use chemistry, physics, and math to figure it out the best way to create new things or to improve a new product. Do you think, is this a description of a child's day, of an engineer's job? What do you think, Dave?
It sounds like an engineer's job, but I hope that it's a description of child's play.
Yes, if you search this specific quote in the internet, you will surprise, because this is the definition of an engineer's job. Dave?
So when looking at STEM and approaches for learning, there's a lot of reasoning and problem solving that's happening. Children are using their minds and their hands. I have a license plate that says hand to mind, because when you manipulate things and you're touching them and feeling them, you're often making that cognitive connection, especially when you're doing it through play and exploration. There's so much to learn when children are given the opportunities to explore and discover. So looking at a child's day, they're incorporating STEM into most of the day in pretty much all areas of play. So when you're looking at science, you're looking at searching for things and sensing things and solving problems, and observing is a big part of science. Technology is really around talking and targeting, testing things, touching them, turning them around, the physical aspect of technology. Engineering, you're exploring and experimenting with building and constructing and designing new ideas using manipulatives. And math is everywhere because you're manipulating things, you're looking at sizes, you're looking at matching things, you're weighing them, and you're comparing them. So you're doing that in all the different parts of the center every day. And it's the teacher who's really needs to point that out to children by asking questions about things and making them observe and notice the things that they're doing.
Thank you, Dave. And what is wonderful about looking at the children's play and a children's day with different lenses is that we know that language of STEM is everywhere, because sometimes we think it's complicated to integrate STEM activities into the daily routine. But when we look at the breakdown of these different activities that children perform every day, we can tell that the science, the technology, the engineering, and the math, it's everywhere, and it's part of the children's day. One important piece that we take in consideration when we think about STEM and how we can integrate this into the daily activities is routines are important for children because they will help children to predict what comes next. And they love to have a stability and predictability during the day. But how we can enhance those activities? So we have a list of actions that we can put in place during their activities. First is ask questions. Every time that we ask questions, we'll get a little piece of their thinking. We can work together as we're progressing throughout the day. We can think in a creative ways to solve problems or to explore and to calculate the risks that they can take while they're playing. And they also can test solutions to problems so that they can discover new ways of doing things that they already know how to do, and they doing it every day in a different way. So if we think about all the different activities that will enhance their thinking, we notice that ask questions is in the first line. So why questions help? What do you think? It's always important to ask children's questions. Why often we receive recommendations about asking children's frequently during the day questions. So, Dave?
Well, as you see here, when you ask children questions, it helps develop strong language development and critical thinking skills. And children will often, especially younger children, when asked questions, will often like shrug their shoulders, I don't know. But when asking open-ended questions or questions that are relevant to what they're doing in the moment, will help them to express themselves. And the other thing to think about is when you ask children a question, give them time to think about it before you answer for them. That's really key. We find a lot of teachers are just like, ready to help them get the answer, where it's amazing the kind of thinking that goes on in a 3, 4, and 5-year-old and what they will say when given the time to express themselves and given the right types of questions that make them want to respond.
And as Dave was mentioning, when you ask questions, you help children with that part of the analytical thinking and the language development. We all know that those are two important components of the class instructional support domain that includes the concept development, the quality of feedback, and the language modeling. And why it's so important to ask the right questions during effective interactions, because asking the right questions will trigger children to learn new concepts, will perform a perfect quality of feedback. That ping pong game that we can play with children where we're providing a really good quality of feedback. When we go from where they are and meet them where they are and take them to a higher level, performing a scaffolding process that will help them to develop a more exclusive and a more fancy language, depending on the age that they are. You want to add something to this, Dave?
Yeah, I do. I want to share that when teachers are using higher level vocabulary based around math and science and blocks in engineering, you know, the children can really learn words like investigations and hypothesis and engineering and architecture, and they love big words. You know, the example I give all the time is they know every single dinosaur word and how to connect dinosaurs, but they don't often hear these kind of words like measurement and all the other words that I mentioned earlier. So it's really important as teachers to start using these words while talking to children so that they hear them, then they start using them, and then they understand the concepts of them. And it becomes a good foundation for them as they move on into kindergarten and beyond. They're going to have some excellent vocabulary around STEM.
And then, as we were talking about before, at some point we always receive the recommendation to provide opportunities and to give more open-ended questions to children, or to ask more frequently children what they're doing and how they're doing, right? But it's like we need to calibrate the right amount of questions and the right level of questioning, because if not, we'll get responses as Dave was describing, like children will do like, I don't know what you're talking about. Oh, I don't know. Because often we use a specific set of questions, right? So let's think about our prior knowledge and our prior experience. When you are with your children, what are you asking? Are you asking regular questions like, what color is this? What letter is that? What is the sound of that letter? That are regular questions. What are you doing? Are we using a lot of conversational questions at the beginning of the day? So are we asking, how are you feeling today? Why are you crying? What happened to your baby? Are we using a lot of the conversational questions to keep children engaged, to help children to transition from one activity to the next? But if we think about higher level of thinking, what kind of open-ended questions are you using? Do you have a list of open-ended questions? Do you happen to have those cheat sheets with open-ended questions in the different areas? Or you're choosing questions, or you're facilitating the activity? Are you using some kind of motivational questioning, like facilitating the activity with questions? Do you know what we're doing here? Do you know what is going to happen? What kind of questions you asking? Would you like to take a minute and jot down a couple of the most frequent questions that you use in your classroom? Out of these categories, you will say most of the time I use regular questions and a lot of conversational questions. Maybe you have a set of open-ended questions, but you're like, sometimes they work, sometimes they don't work. And I don't know about the facilitation questions. They don't seem to be very effective with my children. Let's take a minute before we prepare an activity that will help us to integrate that questioning with the activities. So we would love to integrate that content, that knowledge, and that theory about the art of questioning with real classroom activities. So that's why Dave prepared our wonderful activities with mixing colors. We always worry about colors. And what color is this? I will rate it as the #1 question in preschool classrooms, right? They're building something and then we go around and say, oh, what are you doing there? What are the colors of your blocks? You're drawing and we ask, oh, what are the colors that you're using? So if children are mixing colors, and let's see what kind of activities we can do mixing colors. As Dave is going to perform the activity, think about what could you ask as we're looking at the mixing colors activity.
Okay, great. Well, let's see. Let me see if I can change my camera angle a little bit. And there we go. All right. So I have prepared for you 3 test tubes, one red, one yellow, and I have a clear one because I want to show you what happens when you drop blue food coloring in. And can you see this okay?
Yes.
All right, wait, let me move my fingers. So this is one of the things I love about this video is this is the food color dissipating into the water. This is just a great observation. It's very soothing for children. You don't have to have test tubes for this. You can use any kind of clear container. Beautiful, huh? Okay, so we're going to mix it up a little bit. Now, most children have probably never seen this, so I didn't ask them what they think is going to happen. But what I do want to do is now that we have these 3 colors, we're going to mix blue and yellow into an empty tube. So my question might be, what do you think will happen if we pour blue water into half of our tube, and now we're going to pour yellow water into our blue tube? What do you think will happen? So we give them a minute to answer. You're gonna pour the water in. Well, what's gonna happen when we pour the water in? Any predictions? Wow, do you see what happened there? Now we have done what? We've changed it from blue and yellow to green. Can you see that okay on the camera?
Yes.
I should have a white background. Sorry about that. This is all kind of new. What I want to show you now is another mixing color activity. Here, we've taken a larger container and I filled it with cool water. And what we're going to do is we're going to mix cold or cool because it was, and then we're going to take a glass container and we're going to fill it with hot water. So we're going to, let's change it up this time. And last time we mixed yellow and blue and we got green. This time we're going to make the hot water red. We have the cool water yellow. Now what I'm going to do is I'm going to take some tongs. I'm going to grab my hot water and I'm going to insert it into this cool water. Now, what do you think is going to happen? Make a prediction. What do you think is going to happen with the red water? Well, we made a prediction. And now we're going to submerge it. Well, that was a disaster. That was not what I was hoping would happen. It all mixed up immediately. I don't think you can see the flow very well, can you? All right, let's try it again. I just happen to be ready because a lot of times science experiments don't work the way you think they're going to. So this time we're going to try it again. And I'm going to use a different size glass. I'm going to put the red in here and not use any other color, just to be on the safe side. So we'll only see one color. And I wonder if, probably, let's see what happens if I put it in with my hands. Oh no, I didn't. You know what? Unfortunately, this didn't work the way I wanted it to, because either I probably should have had a salt shaker that I could put in with my hands. With a string, so my hand didn't go in there. But what happens is the hot water will rise up to the top, and you should see a stream of hot water. And then it should sit up on top of your container. So I'm sorry it didn't work the way that I had planned. Probably going to happen to you when you first try it. The great thing about science is doing things over and over and experimenting until you get the result that you're really trying to get.
That is great, Dave, because that could happen in our classrooms, right? So sometimes you prepare all the materials and something is not working. And that's the beauty of having prepared a couple of key questions that will help children to go from the basic levels to higher levels, right? Because what are some of the questions that we could ask? We can ask, what color is this? What do you think is going to happen? Make a prediction. And then when we pick and choose the different colors, we can have a list of different questions, right? And help children to explain what just happened. Is there another way to try this again? Maybe we can see the effect that we were waiting for. Can you make it again? And it's like, what do you think will happen if next time, instead of using this, we can use that? Is there another way to mix colors? Would you like to mix colors in the water? Is there any other liquid that you would like to use to mix colors? What do you think will happen if? And we can play with a different situation. We can play with the different materials. And also, because asking questions will help children to develop higher levels of thinking and higher levels of vocabulary, we can have some words that will relate to the activity that we prepare. Some higher level, I call them the fancy words. Sometimes we say, oh no, that word is too fancy for my little ones. It's never too fancy because they need to increase their understanding and knowledge with things that they know with higher levels of vocabulary. So what about if we ask children to describe when we're mixing as a mixture, right? Do you think it's gonna melt down? Let's, instead of looking at this, can you observe and describe what just happened? Let's touch the different textures. It's smooth. Do you think that color is shiny? And then we can help children to make connections as they're doing. Because remember, those brains that we're building are being built by connections that they do when they're connecting activities with knowledge. Yeah.
I just want to say the good news is we were doing mixing colors, and even though we didn't get the water volcano, we got the color orange from red and yellow. So when we mixed earlier, we made green. Now we made orange, and so anyway, we were able to get kind of a result we were looking for, but not the water volcano.
Well, the water volcano, it's amazing, but we got a result. Thank you, Dave. Well, remember that all questions have value. It doesn't matter what kind of questions you're using, all questions have value. The only thing is that so often we use remember questions to help children to communicate, to get children to interact. Because if you start suddenly asking a lot of creative questions, they will do like, I don't know what to tell you. So we need to use remember questions that will help children to understand and to recall the information that they have, to go from the foundational levels to more complex questions. So the remember questions are the questions that mostly require just a one-word response. Then the creative questions are the ones that it's inviting children to use their imagination and to answer in a more complex way. How we can take children from basic levels to higher levels. So let's review some of the content that we know that maybe we learned before, and this is the perfect time to apply knowledge to what we do every day. Did you remember somewhere in one point of your professional development to hear about the Bloom's taxonomy, the amazing classification system that is used to define and distinguish different levels of human thinking and cognition? We use the Bloom's taxonomy as a tool to measure and organize what we're teaching. For example, if you have children with disabilities or children that are having an IEP or individualized plan, you need to target some of these classification goals to see where are you going. But this classification system is huge. The beautiful news is the National Association for the Education of Young Children, they made an adaptation of the entire Bloom's taxonomy selection to an adaptation for big questions about the Bloom's taxonomy and how we can extend children's thinking. And they use this adaptation to describe the different categories with the specific actions that we use in classroom every day. For example, and you notice that the classification will go from the basics, from remember and understanding, how children can identify, name, count, repeat, recall. Then they can describe and explain and summarize to higher levels of thinking. For example, how I can apply and analyze, how I can identify and relate to, how I can compare, recognize changes, conduct experiments, and contrast to get into a conclusion, to evaluate and create, to express my own opinion about this, to defend my point of view, to make, to construct, to design. So if we put together all the pieces that we have, all these different levels of extending children's thinking are related to most effective interactions in the classroom. Because children are natural scientists, right? They love to name things, to describe. They like to explore with all their senses. They always would like to look at it, listen to it, but they love to touch it, to smell it, to try different experiments. And then they can make predictions. They can understand why my tower is always falling, and apply some of their hypotheses to see if they can build a taller tower. So they can analyze and they can create and have their own conclusion about their own project. And that's why it's so important to have a good set of questions that will better support the different levels of a children's thinking. Another important component and another concept that we know is this SMART strategy. It's like we need to be intentional. We need to be smart because we always need to keep a target in mind. When we know that different milestones that we'll like children to achieve in a certain period of time, we target specific activities. We target specific questions that will help us to measure if children are learning what they're supposed to learn at that moment, that they can attain that knowledge and that can be relevant to what is happening in the world. And it's time-based because we know that by the end of the school year, they need to master a set of skills that will help them to be prepared for the next level. So these are concepts that maybe we have in a beautiful binder that we heard in a wonderful conference, but here we have different activities and different ideas on how you can integrate all of these important concepts into your daily routines. So let's move on into what are some of the key ideas that we can use to enhance questioning. And then we can divide these key ideas into 5 different components. We need to have wait time. We need to have active listening. We need to demonstrate interest, make comments, and ask more. That's how we can keep the back and forth interactions, the back and forth questions and back and forth conversations, helping children to truly understand what they're doing. So Dave mentioned at the beginning of the session that so often we have a wonderful set of questions, but we just rush through the questions too hard into the daily routine that we don't give ourselves time to listen to children's responses. To wait time, to me, I always ask my teachers to take a time out for that teacher. Allow time for children to process what you're saying, to think about and to search for the answer. How we can do that? So often we have those wonderful questions and we go around and we ask questions, but we quickly respond to those questions. Think about when you go to the block area, you go around and you say, oh, what are you building? Are you building a house? Is that your grandma's house? It's like, blah, 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 and then we respond. We need to pause and give them a few seconds to respond. If you can count to 5, if you can count to 10, you will give children enough time to process that question, to think about and to search for the answer. Let's try again. What about you say, why did you choose that? Don't you think that in those 5 seconds, children will respond something? Right? In the meantime, you need to demonstrate some active listening. Because while you're waiting for the response, you need to provide a lot of nonverbal communication cues. So you need to make eye contact. You need to make some verbal affirmation like, I'm listening. I'm waiting for you. And then nonverbal interest. Maybe you can nod your head and say, Maybe you can summarize what they're saying. Sometimes they're thinking about like the one at home, like grandpa, they cannot find that specific word and you can summarize. So alternating asking questions and listening will help you also to determine what is the appropriate time to ask the next question. That next question that will be effective in TOEFL. And then you need to demonstrate some interest so you can keep the conversation going. You need to make an observational statement about what the children are doing before you ask a question. Before you go around and you start throwing questions, give yourself a time to watch and look at what the children are doing before you describe what they're doing. I'm seeing you guys building something with wooden blocks. That's an observational statement. You're not saying how or how beautiful or your own perspective. It's just an objective observational statement. Then you can acknowledge what that child has already worked on it and encourage them to extend their thinking. And one important key component is that you need to be open to the possibility of any answer, not just the right answer, right? You're not looking for what you think they need to say. You're looking for different ways of thinking that children can explore. So what about if we practice one more time? Because we're running out of time and we want to give you more ideas on how you can use more of that wonderful STEM activities in daily routines to enhance your art of questioning. Dave?
All right. Well, I used up both my containers on the last experiment. So we're going to do sink and float with a container with color in it, if that's all right with everybody. As long as you can see it, I guess, right? So can you see that okay, Sandy?
Yes.
All right, so we want to gather up some materials that are, we aren't sure what's going to happen, and we're going to experiment. So here we have a shell, a seashell, and it feels a little bit heavy, but it also is kind of shaped like a boat. So I really don't know. I have never used this before, and I love to do things, and I know teachers are not always comfortable with this, but when it comes to science, it's often the best when you don't know the answer before you do the experiment. And I really don't know if this is going to sink or float. So I'm going to make a prediction, and I want you guys to make a prediction. If I lay it in here the way that I have it, with the bottom curved and the top with the open section, do you think this will sink or float, Sandy?
I think it's going to sink.
Now, I have another one. I forgot to give you my prediction. I think it's going to float. Okay, now I'm going to put it in so that it's kind of on the side, right? I'm going to drop it in on the side, and this time I think it's going to sink. Wow, this is a great example, because what happened here on the one that's floating is the water is held underneath the shell. And so it will float on top like a boat does. But as soon as we tip it and a little water gets inside, how much water will it hold? Oh, I love this. Oh, it was still floating for a minute, and then it sank. Okay, the next thing we have here is a shiny glass. I don't even know what this is. My wife gave it to me. It's kind of a decorative glass rock. So again, it has kind of a rounded shape. And let's make a prediction, sink or float. I think this one's going to sink. Oh, yes, it did. It's heavy. There's no air inside of it. Okay, here we have a plastic egg. Sink or float?
Sink.
Look, I say float. Float. All right, here we have a wooden egg. Sink or float?
Float.
I say sink. Ooh, no. It held on. So I wonder if a real egg, I should have gotten a real egg. That way it's kind of cool if you can compare the same type of item and do it in a variety of ways. And I would guess that the regular egg might float too, but I forgot to get one. All right, what else can sink? Let's see. How about this shot glass? Sink or float?
Float.
So some of the questions mean by, what did you observe when you put the shell on top of the water? And was your prediction correct? What did you observe happen? Can you tell me a little bit about what you were thinking when you made that prediction? What happened when we added a little water inside of there? Can you explain to me what happened there? What did you think was going to happen? And just get in a dialogue about all these different experiments that we can do with sinking and floating. And there's so many that you can do. And you can even chart them and list these sunk, these floated, talk about why, and so forth.
Oh, thank you. So as Dave was saying, you can make a list of the most wonderful questions that your children are going to be participating in responses. You can list a couple of words that will go along with the vocabulary, and then you can extend the activity as Dave was mentioning. Maybe you can do a graphic organizer and help children to draw their own materials, to check their own prediction, and to use more vocabulary. We're going to record our responses. You think it's going to be similar like the ones that happened before. Talk about predictions, materials, cause and effect. So tips and cues, and going towards the end of our presentation, is we need to use intentional questioning strategies all the time. We need to think about what we're going to ask before the activity, during the activity, and right after the activity. Because all experiences, games, and activities will have plenty of opportunities for you to enhance children in these back and forth conversations. Key points to consider: remember to go around, practice that time out for the teacher, watch what the children are doing, listen to their conversation, make a list of sentences with cue questions, and create a list of that vocabulary per activity. So it's a different list of vocabulary of words that we can have in block area, than in the dramatic play area, than outside. And use some of the visual cues for children to remember these activities. Dave, do you want to talk about some of the materials that we have available?
Yeah, several years ago when I was attending conferences and going to sessions, especially around the class assessment. So if you're a QRIS program who's being observed on the class, or you're a Head Start program, what I was hearing was, even from the originators of the class assessment, was recommending teachers use visual clues to put around the classroom to help them with remembering to ask new and open-ended types of questions. So what we did is we created a toolkit for teachers that has over 90 questions in the language of STEM, along with 120 vocabulary words that are dynamic, so they can be changed, versus many of the teachers tape them up on the walls and then they don't really change them very often. So they end up asking the same questions over and over again. So that's a resource that's available through the Discovery Source. You don't need to buy these. You can make them on your own, like teachers have done for a long time. We love how young children are natural scientists. We're here at the Discovery Source, and Sandy and I are available to help support you in any ways that we can. We wish you all the best. And Sandy, why don't you go ahead and close it out?
Yeah, thank you, David. Do you have any questions or comments about this session, about the ideas, materials, content of concepts that we review? This is our contact information. We'll be more than happy to keep in touch with you, and we wish you well. We appreciate everything that you do with our children every day. Thank you for being there for our children and families, and for all of us that are always working behind the scenes to support you. Thank you.
Stay well, stay safe, and keep discovering. Explore and discover, and use lots of vocabulary. We'll see you.